So, yeah, I'm here. I'm here to talk about our Brucewood homes, along with a couple of other different projects that we've been working on. I'm really excited to share I guess, the excitement that's going around the office about Passive House, and talk a little bit about how we're using Passive House as not only a model for construction, but also as a prototype for development, specifically in Massachusetts, as you know, Passive House is starting to become the more of the norm as a lot of the building codes have changed. You can see on screen right now, this is the Brucewood homes that was our first collection of passive homes that we did. Um, and and I'm really excited to show you a little bit more about it. So it's not switching. There we go. As Sean mentioned, I'm the studio director here at Rhodey Architects, and we take on a whole host of different types of projects. We particularly specialize in multifamily, hospitality, single family, commercial work. And I think I'll maybe start by telling you a little bit of a story, and then also by talking about what it means to have a really important, like a really great team. So this is our team for the passive homes at Brucewood. And I guess I'll also say that none of this happens without like great collaboration and great respect for one another. Going kind of left to right, that's Gene Haskins. He's our real estate agent. And it's really important that if you have to have a team member like that who's able to get out there and really explain that passive home is a kind of different way of building, and the aspects of passive homes that make your life better. Next to him is Katya Stassen. She's a certified passive house consultant here at Rhodey, and was the project designer. That's me in the middle. I'm a little smaller than you think on screen. Next to me is Kevin Diebler. He's the principal in charge. And then the next two is Yelena and Dimitri Baskin. So they're the developers and the general contractors for both projects, which I'm about to show you. And I think I'll kind of tell you a little bit how we came upon Passive House. So Kevin in the middle is on the board of directors at UMaine Augusta for their architecture program. And another board member is Matt O'Malia, who works for Opal out of Maine. And Kevin and Matt got to speaking about Passive House at one of their meetings. And Kevin sort of kind of brings that idea back to Boston. And he begins to speak to Dimitri about it. Dimitri is extremely excited about what he's hearing, mainly because he wants to create a series of homes that he can bring to the market that are different than what is typically being constructed here in Boston. So he had a lot that we had gotten some zoning approval on, and we began to construct these 3 single-family passive homes. So I'll go next. So one of the things that Matt really taught us, so we met with Matt, we met with his team from Opal. They kind of talked us through the kind of 5 principles to stick by, and then went over the benchmarks that we were trying to achieve. So obviously air tightness, extremely important, increased insulation, high performance windows, energy efficient ventilation, and reduced thermal bridging. So I'll go through a little bit of this as we get into each one of those components, as I kind of show you some of the details that we have and the construction methods. So we have a lot to kind of thank for Matt and his team for teaching us really about the best ways that they've been doing Passive House. And we're beginning to kind of use a lot of their techniques and things that they taught us, and then also beginning to kind of like evolve upon it. Okay, so these are the 3 houses. They're on buy right. It's a buy right project. It's kind of 6,000 square foot lots. Each home is 2,400 square feet. And as you can see from the plans, they're basically identical. So each house has a living room. You kind of enter through a foyer. There's a living room that you're presented with, dining room, And then to the north of the building is the kitchen. And then along the eastern, kind of southeastern side, which is this side of the building right here, you're presented with a big glass window and a staircase that brings you up to the second floor. On the second floor, really straightforward. There is 4 bedrooms, master suite in the rear, and then this kind of double height sequence that begins to happen because of the stair sequence. So there's a couple things that we're trying to achieve here, not only through using the passive house principles, but really trying to create a great environment for living, which we felt was really, really important, not only to selling the houses, but to create like great awe-inspiring space. So we feel that awe-inspiring space is one of those things that really helps to kind of like uplift someone's experience within the homes. So I show you the plans and I say that they're all identical, but we were very cautious about not making identical buildings that presented themselves urbanistically. So we did a very simple kind of turning and alterations on the facade. So the buildings are placed in a kind of traditional suburban fabric of West Roxbury, a neighborhood in Boston. And we very like consciously wanted to create a series of siblings rather than triplets. We're personally not really in the business of kind of just trying to copy cookie cutter buildings throughout the city. And we want to make sure that all of our buildings really respond to their site. So you can see here that the 3 houses, the one at the top of the hill has a ridge line that obeys the street pattern. And then the one at the bottom of the hill obeys a street fabric related to the VFW Parkway. And then we just sort of blended the ridge lines as they move throughout the property. So what you get is this really unique collection of kind of dancing roofs as they move through. And then, we began to also work through some of the different the window patterning and louvers that were needed. Won't go too deep into these just yet. I'm sure we can get back to this in the Q&A. But this is our typical foundation detail. So 8 inches of EPS insulation on the ground. We have compacted fill and then a slab on grade. So this is the kind of floating slab condition. What was really great about building in Boston is that in this particular setting, there was a lot of ledge. So we didn't need to do any deep foundations. We're really just dealing with a kind of floating slab. So isolation of the building from the ground was one of those principles that we really learned and that we wanted to make sure that we executed well. And of course, the kind of lapping of the vapor barrier is, of course, really, really important in this detail. This is sort of our typical wall section. So we're using 2x8 framing, 24 on center. This is one of those things that the structural engineer was actually pretty delighted to hear about. So the supporting of the structure was not very difficult for them to figure out. 8 inches of blown in over slabs 24. Studs 24 on center, and then we have 6 inches of EPS on the outside of the weather barrier. This is our soffit detail. So it was really important for us to minimize some of the thermal bridging that was happening as we kind of move up through the building. We did want the upper volume to sort of levitate above the first floor. So there was small cantilevers that were happening and some tricks that we did in the skin of the facade to make that happen. And of course, this is our kind of eave detail or sill detail. So 24 inches of blown-in insulation. There's a small kind of ventilation gap at the top here, along with a small ventilation that runs at right underneath this gutter. And then the other thing that's pretty interesting is that we flipped the vapor barrier to the inside here so that the roof is basically not puncturing the vapor barrier when you put the shingles on. And then the lapping of that vapor barrier was another kind of trick that we learned in the construction method, which I'll show you some photos of. So, all right. This is a series of three slides that are just about the construction of these houses. So I think what was kind of exciting is that if you look at this from the outside, people who didn't know much about Passive House or any other architect would say, well, look at this. It's a zip system building. This is very familiar. And I think that that was one of the things that made us set us at ease a little bit. So it's a zip system building. We wanted to make sure that everything is taped properly. So this is our EPS foam before the slab was placed on top of it, with our vapor barrier below, and you can see the large expanses of vapor barrier that are just sort of draped over the sides. So attention to detail there. Really important to make sure that we were taping and sealing all of the plumbing penetrations that were in the slab. That was very, very important. So again, like serious attention to detail. This is a nice little intervention that we did to reduce more thermal bridging when the window heads. So we actually only needed two 2x12, 2x10s in the field to support the opening, but we inserted insulation in between them to help reduce. This is that zip system that's been flipped upside down in the vaulted ceilings. And again, that taping that happens with the vapor barrier coming up as the slab begins to meet the walls. So I guess I'll also just talk about the partnership that is really important to be made with the contractors and the subcontractors that are on the site. So this is Makai from BOJ Construction, and he is doing a window mock-up with Dimitri, everyone at Rhodey, the subcontractors, the framers, and the representative from Sika. So it was just a great collaboration. Everyone's out on the site going through what to do, what not to do, pointing out little problems, and making sure that everyone was on the same page. So you can see that that kind of process is happening right here. We use Amberline windows as our triple glazed component. And then I'll say we took a quick pause here. We did a blower door test at this moment. So this was really, really important to make sure that we didn't have any leaks and that the envelope was performing the way that we needed it to perform prior to putting any of the insulation on the walls, in the walls and on the outside of the walls. So I'd say we passed at that moment and continued to move forward. So that was a really important lesson for us, was to do these checks along the way. And I would highly recommend that all of you do the same. This is where we get into mock-ups. So we, of course, really endorse having your contractor do some mock-ups for you, making sure that the windows are done properly, that the siding looks the way that you want it to look, that you're leaving room in the future for your insulation to be ventilated, that there's no places where insects can get in, etc. And it also just allows for us to be continually engaged with the people who are conducting the craft in the field. These are mechanical systems. So we're using a Zender system as our ERV. And then this is a electric hot water tank, providing the hot water for the building, for the homes. These are 100% electric. And I'll talk a little bit more about the benefits of that. These are some finished images of the exterior. So we're using a natural cedar siding that we collected from northern Maine. They actually drove up there and got it and came back with it. So it was a little hard to find, but we got some great product to put on the buildings. They've been then sealed twice, and they will age a little bit over time. They're actually aging right now, which is a little interesting because they're in a bit of an adolescence. And then we're using boral siding below, which is a fly ash component, which is really good, and we were able to paint that any color that we wanted. And then I was talking a little bit about uplifting space. So we wanted to make sure that the homes were not only thermally comfortable, but that they had a kind of a spiritual quality to them as well. So this is that sort of southeastern light that's coming through the house. It is a 2-story window. It did come with its problems, so I can maybe jump more into that into some of the Q&A. But you do have a 2-story volume here. Light is able to come in at the first floor and the second floor, and it also provides our heating demand, our heating load. So that is that staircase, again, with the power of the sun and the power of light coming in and kind of really enhancing your life. Okay, so the buildings were done. They were all pre-sold before they were completely constructed, which was really nice. They all sold for above asking, or at asking, or just slightly above asking. So these are the metrics and how we did. So the heating demand, we were, passed with flying colors. The cooling, little bit tougher. You can see, especially in 59, just barely making it. But the air tightness is one that I definitely want to point out. We're at a 0.4, and we were supposed to get to a 0.6. So really happy to see how that really worked out. And I'll also say there's a typo here. 63 actually is a 0.4 as well. So a couple of the other things that we learned, and that what are some of the benefits that we've kind of been checking in with the people who own these homes is, so there's been obviously a significant reduction in energy demand. And at the time, the city of Boston required that the houses be solar ready. The homeowners then went ahead and put the solar panels on each house. So this is where we're seeing significant rebates and cost savings from Passive House and from the solar panels. We check in with each one of the owners, and particularly the gentleman who owns 63, which is the one on the bottom of the hill. He's getting anywhere from $800 to $1,000 back per month from the energy company. Now, of course, Eversource is one of those companies that's not going to just give you a check. So he's able to kind of actually just sort of get the rebate and transfer it to his parents and to other people in his family. So the idea of climate resilient construction is another thing that's a huge benefit to this, which gives, I think, anybody who is really living in the Northeast or living in the North, really relieves a little bit of that anxiety of having the power go out. So one of the quick stories I'll share here is the family that lives in 59, the house in the middle. We had a cold spell here in Boston that was -10 degrees for 2 days. They never put their heat on just to see how the house would perform. And the indoor temperature got to about 50 degrees, which is, not warm, but also not cold. A couple blankets, you can kind of get by. So it just gives you a sense of like, okay, this is really resilient. And this is I guess an aspect of the of building in the passive house principles that can really benefit your life. Obviously the health benefits are amazing. The woman who bought 55, she no longer has seasonal allergies because of the quality of life in the house, which has been pretty great. And it's also uplifted her spirit. So she speaks about the notion of no longer having anxiety, which has been really great to hear about. The last couple things that I'll just share is really about the costs. We get a lot of questions about cost. And we really see that it's about 5 to 10% of cost increase on materials, more expensive windows, and you're also dealing with more insulation, and there's more labor involved. But there's also kind of hidden costs within the soft costs. So you're having to deal with additional energy modeling, passive house consultants, additional tests and quality control that needs to get done on the site. And I think that maybe the good thing to hear, the kind of last thing, is that good design and construction really sells. So we've actually had some people just calling us asking about lots of different questions about these houses and kind of what's next. So I'll kind of breeze through this really quickly, but this is kind of what's next for us. So we had Brucewood, we built it, we learned a lot. We've kind of proved that this works as not only something that we understand, but it can work as a development model. And we learned that building 3 houses isn't really going to give you the best margins, but building 18 will. So we have a new piece of property, and this is about 28 acres in Stoughton, Massachusetts. And we wanted to establish some primary goals for what we wanted to do with our next project. So we're sort of wanting to build off of what we learned at Brucewood. We're wanting to maintain as much of the existing landscape as possible, because we're not trying to do your stereotypical American subdivision where you clear cut the land and you put up 18 of the exact same McMansions that are sort of inhospitable to the environment. We want to minimize the home's kind of exposure to one another. We want to kind of create a kind of collective of homes, a collection of homes as they relate to their site. Maximize the relationships with the landscape, and then create a system of houses and details that can kind of proliferate themselves throughout the property. So we did a little bit of research as well when going into this, and we studied and learned a little bit about what it meant to create modern homes in Massachusetts at a kind of suburban subdivision level. And of course, we went to Walter Gropius to learn more and his firm, the Architects Collaborative. So in the 50s and 60s, they were building these sort of American modernist subdivisions, which actually you can read about pretty recently in the Boston Globe came out with an article about how these are selling at incredible rates now. But what we learned and what we know about them is that their siting and their site-specific placement is really important, along with their aspects to the natural site conditions. And they sort of stagger their approach to the street. Their standardized plans, as we did at Brucewood, and which we're going to do again. They developed 3 different house types, which we're going to do again. And then they're marketed towards intellectuals. However, I think we're kind of flipping that notion on its head with the next project, Eagle Rock, which is really kind of marketing towards pioneers and people who are interested in sustainability and living at this kind of next level of the environment. So this is our site, and I'll flip through this really quick. So this is our site. It's your kind of traditional New England woodlands, lots of ledge, lots of kind of old growth trees. There's also a lot of kind of crappy trees in here as well. Lots of kind of leaves and low growth. And then there's also a vernal pool, which is on the site. Okay, so what we did is we broke up the lot into 18 by right lots. So they're all 55,000 square feet. And then we began to identify each lot in terms of like what we could do there and started to understand their characteristics. So the blue lots are the lots that are relatively flat. The green lots have the steepest slope, and the yellow lots are the ones that are most restrained by their buildable areas. So we have a lot of wetlands, we have a lot of ledge, we have setbacks required by the town. So those are the houses that are kind of up against the most amount of like the smallest buildable area. So we took that notion and we developed 3 houses. So we have the blue, which is the flat house. This is a single family that is all on one level. This has the opportunity for empty nesters, elderly couples to come in here, people who want to live on one level, really important. And it kind of sprawls out into the landscape. We have the green sites, which are the split houses. They're multi-tiered, and they begin to kind of make their way and nestle themselves into the landscape. And then the last type is the most compact, and that's the stacked house. So this is the one where we have the least amount of area to build, so we have to go up. Of course, we are using our 5 principles, but we're adding one to what we've learned, and that's really about solar shading as a really important component to what we're doing. Air tightness, triple glazed windows, thermal insulation, efficient ventilation, and thermal bridging are also lessons that we learned and are getting better at. This is the site plan for Eagle Rock. You can see it's a nice collection. And again, our approach here is to remove the least amount of trees as possible and to keep as much of the natural landscape as it can be done. We would prefer, we're not sure this will work, but we would like for you to basically drive through here and almost not be able to see the houses or only be able to get small glimpses of them. So again, this is the flat house. And I'm happy to take you through the plans, I guess, as we move on. But you can see just one thing I did want to point out is that there is solar shading that is just built right into the architecture now. So we took really conscious kind of design cues from the angles of the sun, wanting to block out that summer, but also be able to bring in that winter light and winter energy. The building is actually split into two zones. So the left-hand zone of the plan here is the kind of master suite, and that's on one set of mechanical systems. And then there's the other side, which is on another set of mechanical systems. That's a way for us to reduce the lengths of our runs for the systems. This is the stacked house. So again, kind of big, great, awe-inspiring space here with some kind of connections. And then there is a light monitor, which brings light not only into the home, but to this upper level, and it has this ability to kind of filter down. And then this is the split house. So again, that southern southeasterly facing light, which is coming in and kind of illuminating the hallway in order to bring natural light into all kind of aspects of the house. And then I'll just take just one last thing to kind of talk about. So those were the three houses of Eagle Rock, but I'll just also mention that these are some other projects that have excited the office. So this one on the top here is Just a Start. This is 106 100% affordable residential units in Cambridge, Mass. And this is about to go under construction. We're receiving a collection of submittals right now. And I believe that they're doing ground improvements out on the site. So really excited to share this. This is not only 100% affordable, but 100% passive house. And then the project below is another really exciting project that's been in the office in a completely different type of typology. We're looking at creating a forest preschool about 5,000 square feet up in Glenburn, Maine. So this is a really unique program, but the goal of that project is to try to create a project that is off the grid. So we're really excited to get into the future of that, maybe running on down the line, using passive house principles as well for what we've learned on these other small residential projects. So that's the kind of overview of what we've been doing, and can't wait to have more of a conversation about it. I mean, we're so pumped about this way of building, and it's Zach, I think we talked about it. It's one of those things you kind of can't go back now that you know how to do this.
Oh, so exciting, Mike. What a great presentation, and the details and the story is just fantastic. So we're going to get to questions in a second, and there's a lot. So if you've got any more, put them in the chat. We'll collect them and get to it. But Mike, just amazing presentation, and I just love how Passivos has taken over your office, and you've got all these other exciting projects that are in the process. So amazing stuff. All right, we got to give some thank you to our sponsors. So we're going to do that and be back in a second. So Mike, enjoy the glass of water, and we'll see you in a few minutes.
Indeed,
Right.
Mike, that was amazing. I am going to let's see what I'm gonna steal the screen quick. All right, great. So I want to just take a moment to thank all of the sponsors that make our work at Passive House Accelerator possible, starting with our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you too to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Glavel, Minutair, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks too to our champion sponsors, Bewizo, Gradient, Icon Windows and Doors, Intelligent Membranes, PH Air Seal, and Source 2050. And thank you to our patron sponsors, Brennan, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Sustainable Design. Thank you, sponsors.
Excellent. Again, Mike, a couple things or takeaways for me is I love how you guys included solar shading into your principles. I mean, I've always included as a high performance windows and like in brackets shading because we see a lot in Europe and now it's kind of becoming more commonplace in North America. So love that detail. But again, if you build beautiful buildings, people will take care of them. And the siblings as you created there, they're spectacular. So, and I love how the homeowners are starting to tell the stories of each of the siblings and the differences and the growth spurts and all the fun things that are occurring in each of those units. So great stuff. So we'll dive into questions. I see a few more coming in, so we'll gather those up and put them in the queue. But first is Rachel. So Rachel, over to you. Want to unmute and ask your question? Go for it.
Trying to figure out where my unmute button was.
There you go.
So my question was, how do you convince or how do you sell Passive House to investors? And I'm thinking, I just got an email from a friend of mine back east. I'm in Colorado. She's getting involved in a project in the Hudson Valley, and I'm going to reach out to her and recommend Passive House, but I don't know how to get them involved or what would be the best thing besides just telling them about it. What would be the next step with a 163 acre development, type thing?
I mean, I think that one of the things that I guess what I'll say that we're finding it easier to sell the idea now that we have the stories and the statistics to back up why we did this. It's been great to just hear about quality of life and hear really about the kind of performance aspects of the buildings now that people have lived in them. So I think that's probably the biggest thing that I'd kind of begin to recommend is, it's a relatively new idea here in America, at least. And I've actually spoken to a series of real estate developers at the Boston Architectural College. They were students, and they're more like, why would we do this? Like, why would we spend this amount of money to do this? It doesn't make any sense. It doesn't work in our pro forma. Like, there's all this upfront cost. And if we're just gonna sell the buildings anyway, like, why do we care? And it was kind of an interesting moment because you say, well, yeah, you got to do it because, well, in Massachusetts now we have policy that is almost making you do it. But you do want to be able to sell the notion of a great quality of life, sell resiliency, and be able to prove the fact that there's reduced bills. So it's like a little bit in a way like you're having to invest in buying an electric car, even though because they cost a little bit more, but you've kind of relieved yourself of some of the long-term costs. So it's a really interesting conversation. I think it's kind of beginning to formulate itself a little bit more now that we have more data in America to back it up. But I think the debate will go on for at least a couple more years.
Yeah, great points there, Mike. I mean, I'm in a 6 unit development too, and policy in Vancouver here is definitely driving it because we're getting there. But when you get to experience that passive, like your clients have, I mean, I don't think they would go back either. And hearing their own individual stories, it's just amazing. And so more of those stories is what we need to share, and hopefully people will just realize it. So yeah, it's interesting on your. Sorry, go ahead, Zach.
Sorry. I just wanted to interject, and I'll share this in chat. But Mike Ingui, the founder of Passive House Accelerator, I think he's on the call, but he does he shares some great insights about how to communicate about Passive House. And Mike, you're totally right on. So this is just building on what you're talking about, and really just to emphasize that to lead with the amenities, not to lead with when you're talking with a client or somebody who's new to the concept. Avoid the temptation to talk about the building science and the blower doors and all that, and instead lead with amenities. So there's a video that we'll share of Michael kind of talking about that.
Yeah, it's funny. It's like that elevator pitch. It's like that teacup. We're so used to like making sure that the clients get the Kool-Aid, but it's like, how do we give them the Kool-Aid? Start with the teacup, start with those benefits. And then if they're interested, maybe in the building science, and you bring out the jug. And then when they're really enjoying it, that's when the fire hose opens up. And I used to just want to open up the fire hose and just dive into it. And I've had to kind of learn to step back and use words that Mike Ingwe, brought up. And sometimes the building science doesn't capture the audience, but like the stuff you spoke about, the comfort and the health and resiliency, especially now with so many examples. I mean, last week we had, we had, a project in Houston talking about resiliency and the stuff that happened in Texas 2 years ago. And to me, that was just the big awareness of just really resiliency. Even though in Vancouver with forest fires, it really had to change my kind of language from sustainability to resiliency, because people get resiliency. All right, moving along. Thank you, Rachel. We're over to Ines. Ines, do you want to unmute and ask your question?
Yeah, hi, Mike. Thank you for your presentation and sharing the construction details. So I have a question. I saw in the details and you talked about the EPS and the blown insulation. I'm just wondering if there are alternative materials like straw bale or hemp that are more that are healthier and more sustainable, and if those have been used and proven to provide the level of enclosure seal, the seal that you need for passive house.
I'll say that, and I think I noticed this as well, like in one of the in the chat, like the notion of using EPS on the outside or even using it at all is a interesting, or I guess a uncomfortable thing. So we did look at some more sustainable materials. When we did the Bruce Wood homes, we did look at wood fiber insulation for a brief moment. It wasn't cost effective at the time because you weren't able to get it in America. And we were also in COVID. So the problem was that we didn't know, and this is also like, I think the Suez Canal was shut down. So we were having trouble getting product from Europe. So we didn't have that to lean on. So that was one thing that was a little bit tough, is that the cost of it was too high as it related to the EPS. We knew that we could get it to work with the EPS, so we decided to go that route. We still like it under the foundation, although we are looking at a couple more sustainable ways to do it. Foam glass comes to mind for the Eagle Rock project. And the Eagle Rock project, we're also looking at using Timber HP, which is a wood fiber insulation manufactured in Maine. We don't know if it's going to be ready for us completely, but it is on our mind. I guess I'll put it that way.
Thank you.
You're welcome.
Yeah, excellent. Love how you guys are looking at improving and not only just the operational carbon, but the embodied carbon. Great stuff. Moving along, we've got two Marks in the queue, but first we go to Mark Rosenbaum. Mark.
Thank you. Mike, that was great. I really enjoy watching your process and how you've brought your whole team along. So I'm going to be the person that pisses everybody off and say, I've been with this for a long time. I was a founding board member of FIAS. And the single family model in cold climates like ours, the amount of insulation you have there is just, since I'm mostly working on affordable housing and they're small, not big buildings like you showed at the end, there's no way we can afford that. But what I've seen from a lot of modeling, but then a lot of measuring, is that at half of passive house, in other words, instead of 4.75 in the old German system, 9, that the houses that I'm doing that are affordable single family, the heating is 20% of the total. And the occupant behavioral choices are significantly over half. And so, particularly with the Germans, when they didn't let you use any PV credit, it made no sense to me to have 12 inches of foam under a slab and not being able to count PV to get to your arbitrary, ultimately, these are arbitrary numbers. So I guess I'm curious in terms of the first 3 homes, since they're up and running,
Mhm.
do you have your modeled results compared to actual usage in those buildings?
I would say no, not yet.
Well, I think that is really where people need to focus. And these days, you know, I used a lot of what is now SiteSage, and now I've used a lot of e-gauge monitors. And I've recently found one that probably some of you have already used because you're ahead of me, the Emporia system. And they go in the panel and you get circuit by circuit monitoring. And you're really looking for, let's say, the 10 most important circuits. But I think you've got to get that information. And when you start to see where the energy is going, it helps, you know, if you take passive house certification off the table for a minute and you just say, I want to make the decisions that are really going to benefit my client the best. And again, my perspective has changed so much because I'm mostly working on either nonprofit or affordable housing. The next dollar is not R60 in the wall. You know, it's just really, and the model will tell you that if you're not hitting 475. And I recall working with a developer doing, again, in Massachusetts, buildings. And I said, you could use a less expensive, you're fighting budget, you could use a less expensive ERV. You could go from the Zender to a Panasonic.
Mhm.
I said, and save $2,000. And he said, I can't do that. And I said, why? He said, I'm right on the edge of 475. But that $2,000 could have been spent somewhere else in his project per unit, especially little. These are 1 bedroom mostly. They don't need a Zender. I love Zender, spec a whole bunch. So anyways, I've said a bunch of, you know, verbal diarrhea here, but I'm encouraging you to measure what you're doing because you pulled all the pieces together so well, and you've got to learn from what you've done because you're doing it. Thank
Right.
you.
Yeah, yeah, absolutely. You know, I'd say that the whole Panasonic thing is pretty interesting because we are just considering that on the Eagle Rock houses. We are looking, it's really important for us to be efficient with our costs, right? So we can't take multi-million-dollar homes that are for Boston and start to like populate them all around Massachusetts because the market's not going to be there, right? So we're looking at ways to make sure that we can still meet the metrics, where at the same time lower our costs. And that Panasonic question came up right away. We're working with Passive to Positive on the Eagle Rock project, and they've been amazing with trying to think a little bit differently about the way we're going about things. You know, we know the way that we've done it, and we know that it works, but we are still open to being, you know, bending, I guess you'd say, in order to make the product better. So that's certainly been on our mind. And the other, just quick other comment that I'll make about the measurements is that, you know, it's a little hard to go back into like these homes have been sold, they're off to somebody else, they're not our responsibility anymore. However, not that they're not our responsibility, but we don't have the ability to get in there and measure. However, I will say that the gentleman who owns the middle house is an engineer for GE, and he is measuring. And he has all kinds of gizmos and great things that he's doing to kind of check in on the performance of the house. And we're starting to receive some of that data through Dimitri and his team. But he's not really like directly to us. So anyway, it's great point, and it's something that we're going to begin to collect.
Yeah, thanks, Mike, and thank you, Mark. Those were really important points. So, I just as a follow-up, are you in your practice, Mark? Are you finding that the FIAS approach is are you applying the FIAS approach to your projects now, or where
Versus-
are you at
Zach, versus what? I mean,
versus PHI? So
oh,
meaning
no,
like
I'm
in
definitely
terms
with,
of like the optimize
oh,
the cost
definitely
optimization.
American.
Mm-hmm.
And, as I've watched the larger projects go up, there was a project in Boston, which is a skyscraper. And Stephen Winters Associates folks were presenting, they always use the German one. And I raised my hand and I said, okay, so you met the criteria for cooling and it works out to 2,700 square feet per ton. There's no building ever built that will hit that. So the German arbitrary numbers are so far from what you can actually achieve in these buildings that to me, it's meaningless. Whereas FIAS has adapted to different climates and how we really build buildings. So as the criteria get more removed from what's really achievable, I said, what do your mechanical engineers say to 2,700 square feet per ton? And he said, oh, he's doing his own loads. So that says, yeah, we're totally ignoring what the PHI spreadsheet told us. That doesn't work for me. And it may work for the rest of you. Mike, for you, if you're starting to work on those bigger buildings and you're using the PHI numbers, you're going to end up having to do all your own loads for the actual systems because you're not going to get the cooling systems sized right. So Zach, I mean, I think that for me, first of all, I'm not that committed. I did early passive houses because I was so happy to see that structure coming to this country. Because remember, this is all based on North American work originally. I mean, not that many of you are that old, but this all started here in North America, not in Germany, not in Scandinavia. And when I first met Kat, she said to me, oh, you have been doing passive houses longer than Wolfgang. And I said, yeah, but we just didn't call them passive houses. So the process of optimizing where you spend the next dollar is always distorted by having arbitrary goals and targets you have to meet. However, if you haven't done it before, like what Mike has shown us is having these, I'm going to still call them arbitrary targets, is the discipline that teaches you how to do this. But once you know how to do it, then you've got more flexibility in saying, should this project be a passive house? Am I going to end up with 40,000 cubic board feet of foam to meet an arbitrary target? And my answer is, I hope not. And I recall asking Phil Kaplan of Kaplan Thomas when they showed a school, he had a foot of foam under a 10 or 12,000 square foot footprint. A foot of foam 100 feet from the perimeter is doing like nothing. And I said, so had you compared the cost of extra 80,000 board feet of foam with what that money would buy you in PV panels? And he said, no, I can't do that because I have to meet the targets. Right.
Oh.
And we're at the top of the hour. So if you do need to leave us, we do get it. Hopefully we will see you soon, either next week or in the upcoming weeks. But again, as Kim just mentioned, lots of different avenues to get passive house knowledge from podcasts to magazines. So check that all out. But we're going to deal with more questions here in the final 15. We may not get to all of them, honestly, but we'll do our best. So Mark, if you're still with us, from Design Distillery, over to you.
Can you hear me? Hello? Okay, perfect. So my question is just sort of, I'm looking at the numbers and Mike, you had mentioned, one of your buyers of one of these houses, how they were monitoring when the power went out or when they had extreme weather, how the home was dealing with that change in temperature. But My question's more related to, you've got a house that's 0.4 air tightness, air changes. How are you dealing with the air circulation when that power goes out? Because the answer that I typically get when I do that type of research is I'll ask the vendors, or I'll ask, the EAs, what's the best approach here when the power goes out, because we've built so tight. How are we doing with that? And the best answer I get is open a window. And I mean, I'm in Canada, as some of you guys are, and that's not necessarily the best approach when the power's out for a week during an ice storm. So, what sort of strategies have you built into this house, or maybe anyone else in the panel, like as far as dealing with the situation? Because we've got clients that want to start building tighter, and that's an answer that I just really have not, or a question that I've really not gotten a good answer about. So I'm wondering if there's something an approach that you took, or if anyone else has, as far as dealing with that.
I would say that there was no approach for the Brucewood homes to do that, right? And I don't, and again, we weren't trying to like turn the power off, I think, and we weren't necessarily thinking at the time as we were learning how to do this, really to ask to have the know-how to ask those questions, I guess, yet. But what we were learning from just the people who were living there is that these are the things that they were trying to figure out. And I think we were excited to hear how they were performing. So with that in mind, when we move over to Eagle Rock, there is some resiliency packages that we're considering as battery backup that can be sized for each home based on the amount of energy that they're going to need for, let's say, 48 hours. And then they wouldn't be included. They would be like an add-on that would be pre-engineered for each of the house types that the buyers could purchase as a result, as a way to have a longer amount of time that they could be without power. So that's kind of a roundabout way of answering how we're dealing with it. But I think that it is the notion of having power when there is an ice storm, or that when there's or even in the summertime when there's brownouts because of too much usage. We are thinking about that as homeowners ourselves, and what could be applicable to these houses as they go under construction.
Yeah, great response, Mike. And Mark, it's such an interesting thing, right? Because at the end of the day, you're thinking of just survival, and you're choosing which survival techniques are you taking upon is, you want to be in a comfortable space where the temperature is okay, but the whole indoor air qualities is, a discussion that honestly, I didn't even kind of realize until COVID, and then I bought an indoor air quality, and now I've got one of those air nets that I travel with because I'm just so fascinated about different air quality. And I mean, we actually end up living and staying in spaces that are not good for us for longer than we think, but we actually don't notice it. We might feel tired, might feel different things, but we just don't notice it. So you're right. It's just the more data that we can gather. Because when again, we're talking earlier about resiliency in Texas, and the story that was there. Yeah, they didn't manage their quality. They just cooked outside. But you're right, there's 2 or 3 days where you would probably assume that indoor air quality was higher limits, but their pipes weren't bursting, and they weren't like the neighbors having to move out. And so you're right, is like, now that we've gotten better data about indoor air quality, you're right, you'd want to have some type of battery backup just for that particular system. And then it comes back down to, okay, well, if you're doing your fresh air machine, now you want the fridge, and now you want a few other things, and all of a sudden your battery is taking on those other items you want to have to survive those times where our shelter is not able to provide us the full level of comfort that we just expect from day in and day out. So yeah, it's tricky. And talking to Mark too about embodied carbon and materials between solar panels and and foam insulation, it is tricky, but luckily we're getting more data to be able to make these better decisions. And so yeah, some of those earlier passive houses had more foam and did more maybe potential damage with embodied carbon than the operating carbon. But it's the more data we get to, the better that we can provide our clients. And again, a lot of buildings don't have the passive house levels of comfort. So it's just this scale of just trying to do better every time, and just keep learning and sharing like we're doing today. So no, great question and great comments too. All right, so keep going. Thanks, Kim, for keeping me up to date with the queue. We are headed over to A. Conrad. A. Conrad, you still with us? All right, give you 2 seconds just because I know there's lots going on. Okay, moving over to Mark Houston in Alaska. Mark, you still with us? No, Mark's gone. We're gonna keep going down.
Yeah, I'm here.
Perfect. Go ahead. Thanks, George.
I had the same questions that were answered before about the foam and the alternatives, and that was very well answered. COVID was a big factor for all of us.
Yeah,
And,
I would also say that yeah, I mean, COVID's a huge thing, and the other interesting thing is that EPS is manufactured in Rhode Island, so it is a very short truck ride to the site
Right.
from there,
Yep.
which also kind of helped we got to go down to the factory, we could kind of see what they were doing, but I think everybody here kind of understands the negative aspects of it as well. So we're
Yeah.
learning. I mean, it's something that we're gonna continue to test and see what else is out there for us. And again, we have a system that we know can perform and work. And then it kind of begins to be a different question about carbon as we do more of these.
Yeah,
Yeah,
Mark,
we've got EPS made right here in Anchorage, and I'm still really pushing people for rock wool for under the slab and underground, below ground walls. They're catching on. I'm fighting an uphill battle, but I'm getting little victories all the time. Because it is a cold climate and we've got to cover for
Yeah.
that.
Yeah,
Thanks.
you're welcome.
no, great stuff. Now the next one is Nuria. Apologies for saying it incorrectly, but you're still here, so go ahead and ask your question.
Sean, I
Hi,
think.
go
Go ahead. Sorry.
I hope you can hear me clearly. Well,
Mhm.
thanks thanks for a very good presentation, Mike. My question is, have you made an analysis of return of investment on how long would it take you to absorb the cost of extra cost of construction in comparison to energy savings, and if there are any tax reductions for property tax for near zero energy demand buildings in your area?
Yeah, I think this is the same. This is a very similar question that came up out of the real estate development class that I spoke to. Is how do you what is the life cycle cost of the way of building right now, and way of building in this method? We don't have that data yet. I think that the good thing is that with the houses that we have built, we are in still constant contact with those owners. And they've been good about helping to share the information. But I guess it's going to be some time before we really know if what we built out there is saving money in the long run or is spending more in the short term long run. So we totally hear the question. I'll say that at Rhodey here we're still relatively new to this, and we don't have a
Ronnie just
backlog
got back to me.
of kind of data
He said,
to go
unfortunately,
off of just yet. So I guess the answer is noted, and we're gonna continue to collect that so that we have the answer in the future.
Yeah, Mike, and the fact you guys have constant contact with the homeowners, I mean, I'm always intrigued to see after a year or two, can you do another blower door just to see the test and just to, again, to see that consistency of the systems that they're
Yeah.
still working in. And I think it's interesting too, is like your team there about the culture. I know I have Mike Steffen in Portland where, he's promoting a 500-year building. And that was like the goal is how could it evolve? And so if you've got a team that's looking for at least 200+ year homes and trying to make good decisions, and you've got a culture within that team to just keep improving and being able to meet with the homeowners and get great feedback, that's a great continuous improvement loop that you guys have going on right now. And again, what's on the boards is really exciting projects, and the fact that you're doing more high performance, more passive projects, super exciting.
Yeah. And we're in Mass, the codes have changed. And I think a lot of architects in Massachusetts are still trying to unpack what all that means. But You know, we have two other projects that are in design right now that I didn't show, which are affordable housing projects, which are they're in CDs, or we just sort of finished like 70% CDs, and they're 100% passive house because they're in the city of Boston. We have two projects that are in entitlements in the city, and it's insane, really, the amount of scrutiny that they're getting from an energy standpoint very early in the process, which is delightful, but also a part of the process that you almost have to calm down a little bit, because we do have, you know, we have communities that need to put in their input, and we got some feedback from our passive house consultant on one project where he's like, oh, the window to wall ratio might be too high. And we said, that's great, and we understand that, and we're willing to fix it. However, we don't even know if this building's going to get built. And we don't even know if this is going to be a 4-story building or a 5-story building. And although I appreciate the question and the need to want to answer that, I almost want we need to be nimble enough to know that things are going to change as we move through an entitlements process. So there's that aspect too, which is kind of hitting us.
Yeah, intriguing. Okay, I know Tom Phillips got a couple questions. So Tom, go ahead. We're kind of at the top of the hour here, sir, top of our time, but go ahead.
I'll pick maybe the most pressing question, but also thanks again for a great, short, sweet, but enlightening and very encouraging presentation. And it's great to hear what you're working on now. I just want to talk about resilience and ask you a few questions about how you think you can address future climate. It doesn't seem like the standards of policy in Massachusetts are really doing that yet. I know, you know, it's been a hotbed for the research on that topic in Massachusetts and Boston, MIT and other places. So you know, when we heard the story about people running their house without power and so on, that's great. And we heard about how, in terms of selling passive houses, resilience and comfort and all that are critical. So the suggestion and question I have is, how can you present objective kind of data for marketing and performance assessment on resilience? Because there are these various overheating standards and passive survivability that are, you know, not only, excuse me, for power outages, but for life cycle performance. And so you could sell it on a life cycle operating cost basis as well as survivability during power outages. So, you know, I'm a show me the data science guy, but there's a lot of people that are you know, buying homes that want to have, you know, like a miles per gallon rating. What's my house? How's it compared to what else is on the market?
Right.
And so I think, you know, with those modeling tools and even measurement approaches, that would be a great marketing and health and safety feature.
I mean, I guess one of the things that maybe one of the metrics that I think maybe identify the most with people, like I'll just say the typical buyer, right, is the air leakage metrics, because it seems to me that that's something that people can that resonates with somebody, you know. And so I live in a 100-year-old house here in the city, and let me tell you, it just leaks like crazy. And it's not because we don't have insulation on the walls. It's just the windows are bad. The taping is not there. You know, we have the thermal bridging is insane because we have gigantic old growth studs. You know, and so there's all those things are happening. So when you look at a metric like, you know, ACH 50, and you see what that means, to just put it in perspective, like my house is like a 15 on that scale, you know, and like typical construction is maybe like a 5. Whereas we're below 1. And I think that's at least one thing that I think when we begin to market this more is some metrics that we can kind of put some humanism to, I guess, where the drafty windows are a thing that somebody would feel, you know, and it's something that I feel all the time. I mean, when in the winter here, I have to, you know, we have to have the special shades that come down in order to prevent some drafting. You know, my wife puts a towel under the door sometimes. And it's just, it kind of is what it is. I mean, my house is 100 years old and it was built in a certain time, way. But I will say that, if we were to move and build our own house, we're going to build a passive house. And because I know I can kind of celebrate the differences, So, I mean, we don't have all those metrics, and I think that it's something that we need to collect, and we need to do a really good job, especially in the marketing websites and trying to sell these things and, talk about life cycle costs. And talk about how the energy demand is going to reduce their power requirements. But I'd say that just that for me kind of just feels like the thing that would resonate the easiest with potential buyers is just the air tightness qualities.
Yeah.
It is those things too that are kind of like, I guess it's some of the more like less performance stuff that really makes you think. It's the sound quality, unbelievable. I mean, the 63 house is right on top of the VFW Parkway, which is a very busy road here in Boston. And you step into those houses and it's kind of like stepping into a little bit of an oasis. You don't hear anything, which was really surprising to us. But after it was built, we were surprised, but then we kind of thought to ourselves, well, of course, right? Why wouldn't it be? Given what how we built this. That kind of stuff is what I think we're really leaning ourselves on, because it's the human qualities that are kind of unmeasurable right now that people can identify with.
Well, guys, great question, Tom and Mike. We got to wrap things up. We're a little bit even over. So
Okay.
everyone's got to head back to their work day or to whatever they're up to. But Mike, thank you very much for just an amazing presentation, level of detail. Again, being involved as a co-host of Construction Tech, we could have just an entire event just talking about your wall assembly and those soffit details.
Yeah, I know.
Very amazing work. And but again, beautiful cladding. Wraps up all those amazing passive performance techniques. So Zach and Kim, I'll let one of you hit the ejection button, and everyone, we'll see you soon.